Hey guys, I want to walk you through the area of a lune project that you're going to be doing. So, if you read through it does kind of lay everything out for you, but I know there's always some confusion, and especially with us not being together, I thought I would sort of explain some of the parts that you might get confused on. So, first of all, what even is a lune? So, I have a picture here of two circles that overlap each other, and it's the region in between the two circles. So it kind of forms this crescent shape, looks like a moon. So you see the resemblance there. So that's what we're trying to find the area of, the area in between the two circles. So a few things that we're going to need to, in order to do that. One thing you need to remember from geometry is what a sector is. If we take a circle, take its center, draw a radius, two radii out from that center, the region in between those radii is referred to as a sector. I like to think of it like a slice of pizza. Okay, so if you take a look down here at figure 1, a couple things that they tell us up here. The triangle ABC is an equilateral triangle with all of its side lengths as S. Okay, we're going to be trying to find the area of this lune right here, which is this dark region. So what you need to imagine is that we have two slices of pizza kind of overlapping each other. So one slice of pizza is right here from B along this arc and then out to A and back. So this sort of white area, that's one slice of pizza right there. And it is sitting on top of another piece of pizza that's sort of shorter and wider. So that piece of pizza goes this way, all the way here, and then it comes to D. So for this sector, this slice of pizza, the radius is BD. For this white piece of pizza here, the radius is AB. See the difference there? See those two different... If we elongated them into full circles, hopefully you could see that there's a smaller circle here and then a larger one here. And then that space in between them forms our lune. Okay, so in order to find this, we need to know a few other things. First of all, you need to know how to find area of a sector. So here's the formula. I'm just giving it to you. It's 1/2 the radius squared times theta. And you want to make sure that theta is in radians. So when we're talking about theta, remember, that's just going to be, if I was looking at this one here, it'd be this angle right here. Okay, so I'm going to need that angle in radians in my formula. Okay? So down here, we just, some other things from geometry that you need to remember. Area of a triangle, 1/2 base times height. Don't forget about our special right triangles and Pythagorean theorem, of course. And then another topic that comes into play quite a bit throughout this is a median and the centroid. So if you recall, this is just to kind of jog your memory. If you have a triangle and you draw a median goes from the vertex to the center, the midpoint of the other side. So if I told you that this entire side of the triangle was length S and D is the midpoint, that means from B to D and from D to C are both 1/2 S, or S over 2. When you draw in all three medians, they meet at this place called the centroid. And the centroid divides each median into two parts. You have a little part down here and a bigger part here. But it's not just little and big. It turns out that this is exactly 1/3 the length of the entire median, which would mean that this bigger part is going to be 2/3 the length of the entire median. So if I had told you that from A to D was, let's say, 30 inches, that means that GD would be 10 and AG would be 20. Okay? If I had told you that AG was, I don't know, 50 inches, then that would mean that GD is only 25 and the whole thing would be 75. So AG is going to be 2/3 of the entire length. GD is 1/3 the entire length. And don't forget that 1/3 is half of 2/3. So if I know this one, this little piece is half of that. Or if I know the little piece, this piece is double that. And then all together they would make 3/3. Okay, so that's kind of important to remember. And then let's flip over to the last page. There we go. Okay, so here's basically what we need to do down here. We're going to figure out the area of this entire shaded region in 3A. Then we're going to find the shaded region in 3B. If I take this area and I subtract from it this area, what's going to be left behind? Just the area of this crescent, just the lune, which is exactly what I want. So that's my goal. I need to find an expression for the area of this entire shaded region and then this entire shaded region and subtract those two values from each other. And my answer will be the area of the lune. Okay, so now how do you do that? Well, this slice of pizza here, right? We know the formula for area of a sector. We just did it on the other sheet. 1/2 the radius squared times theta. So you need an expression for BD. That's the radius of this sector. So you have to come up with something for BD. And you also need theta, which is right here. Now, how are you supposed to do that? Well, if you, I guess we could do it right on this triangle. If you were to just extend these, so this just comes down, that's 90 degrees. You can extend the others too if you want. So if I just extend all of my medians, I don't even have the third one drawn. That's okay, we don't need it. So remember a couple of things. ABC was an equilateral triangle, right? And AC was S. So if this is the midpoint, weren't each of these S over 2 and S over 2? What else do you remember about an equilateral triangle? Don't you know this angle right here? So if you know this angle, now, doesn't that make these special right triangles? So this whole thing is a special right triangle, this whole thing is a special right triangle. So you should be able to come up with an expression for B. I'm going to give this point a name here just so I can talk about it. So BW is now a median in my triangle where D is the centroid. So that's where the whole, this is 1/3 of the whole thing, this is 2/3 of the whole thing. That's where that's going to come in. So if you know that this is S over 2, you should be able to come up with an expression for BW using special right triangles. And then knowing that BD is 2/3 of BW, that's going to get you your radius for this sector. Okay, so you'll need that radius. And you'll need, that angle should be pretty easy to find, especially once you pop that in. Okay, so you should be able to find that, and then you'll be done with figure 3A once you plug it into the area of the sector formula. Okay, then you're going to do the same thing with 3B, except in 3B, this is the slice of pizza you're looking at right here. So just be careful because your radius now is all of AB and this is your theta. Okay, so it's different than this one because this one slice of pizza was right here and theta was there. This one, the slice of pizza, is this whole thing. Now, you might be thinking, well, Miss Sabia, if I just want the area of this shaded region and this is the slice of pizza, then you're counting too much. You need to get rid of this white area. Yes, I agree with you. So to find the area of just this shaded region in 3B, you need to find the area of this whole slice of pizza using the 1/2 r squared theta that we just talked about. Same thing that you did up here. It's just that AB is your radius, and this is theta. But then you need to subtract this unshaded region, this sort of arrow-shaped region right here, A, B, D, C. You need to get rid of that because you want just this. So how are you going to find the area of this thing? Well, again, it's actually not that bad if you do this. You can draw that line, and now what you have is two congruent triangles right there. And you should have enough information to be able to find the area of one of these triangles and then just double it to get the area of the whole white region here. So you're going to find the area of the whole sector, the whole big slice of pizza here, ABC. You're going to find the area of each of these two triangles right here. You're going to subtract that from the area of the whole piece of pizza. That's going to leave you with the area of just this shaded region. Once you have that finished, then you take your answer from 3A and you subtract your answer from 3B. And what is left behind is just this area of this little region right there. Okay, good luck.